Mm, Why this question is so hard?
Hmm. Maybe I should sleep. Why?
Huh? What? What am I doing here? Yesterday I at the study room. Now why am I at the park?
Okay, good. You're awake now. So, I will teach you about IEEE floating point. Let's go. We will talk about why IEEE is developed. So, what is IEEE? IEEE is stand for Institute Electrical Electronic and Engineer. So, how does it got its name? Long before, use computer use different format to calculate number. Let's say computer A use format A to calculate 1 plus 1, and computer B use format 2 to calculate 1 plus 1. This can result to inconsistent answer, which can make all the calculation is not the same. So, to solve this problem, Institute Electrical Electronics and Engineers decide to develop a standardized format for all the computers, which is IEEE 754, or we can be known as IEEE floating point. So, why we use IEEE instead for other format? So, as we know, computers cannot calculate directly from decimal number. It can get slow if you use that. So it need to use a binary number. So IEEE had to convert decimal number to binary number. Let's say if I got decimal number 4, IEEE will convert the numbers into 100. Okay. So IEEE also help users to communicate with computer if there is something wrong to debugging the binary numbers, because binary numbers, after we convert decimal number to binary number, we can convert it to hexadecimal number. So let's say I've got a certain number, and then I convert it into binary numbers. Then for users to simplify for the user to debugging the number, he can just convert it into hexadecimal, because to change number from the binary number to hexadecimal number is easier compared to change from this binary number to decimal, because in hexadecimal we use 4 bits instead of 1 bits for decimal number. That's all.
Yeah.
So for the first step, we need to convert decimal number into binary number. So the number that we got is 37.6875. So we need to separate the number 37 and 0.6875. So first we divide the 37 with 2, and we take the balance like this. And then after that we need to we take the 0.6875 and we multiply it by 2 until we get the result is 1.000, like this. And then we take for the multiply, we take the number if it is more than 1, more than 1.00, then we take the 1. And then if it's less than 1.00, and then we take 0. Then we take from the up to the bottom. Then we got the 0.6875 in binary. Then we combine the number we get from divide and multiply. Combine it together, then we got 100,101.1011. Okay, that's our binary form for decimal number 37.6875. Okay. So after we find the binary number from decimal, we need to find the sign for the binary number. To find it is really easy. If the number is positive, if the decimal number is positive, the sign for binary number is 0. And if the decimal number is negative, the sign for binary number is 1. So in our situation, which is decimal number is 37.6875, is it a positive or negative number? Of course, it's a positive number. So the sign for our binary number is 0. Okay, that's all.
So, step 4, we need to find the bias exponent, which is 127 plus exponent is 5. So, 127 plus 5 is 132 in decimal. So, we need to convert the number into the binary form, which we will convert, we get 1000100 subscripts 2. Then move on to the next part. Bro, come here, bro. So you have found the weird exponent, right? Then you need to find mantissa. So, mantissa. First, in step 5, if you want to find mantissa, you need to find the significant. Where you can get this significant? Back to the step 2. After you got 1.00101111 times 2 to the power of 5, you need to take the number after the point, which is 001011011. So that's the significant. Then after you got the significant, you can find the mantissa. But how is it? So basically you need to add 0 to the significant until you got the 23 bits, which means after you got 001011011, then you need to add 0 at the back until all the digits become 23.
Okay, so in step 6 or our last step, we'll convert all the information that we have into IEEE formats. So let's gather all of it from step 1 until step 5. Okay, so we will look at the sign of the number. Since in IEEE format, in binary form, we have sign, bias exponent, and then mantissa. So we look at the sign. So the sign is positive. If the sign is positive, I already explained at the previous step, which is if the sign is positive, it will get 0. So we put 0 at the sign, and then we need to look at the bias exponent. So what is our bias exponent? Our bias exponent is 100,00100. So we put it after the sign, and then for the rest of it, we put the mantissa bits. So this is not complete. This is not complete yet. We need to convert the binary numbers into hexadecimal number. So this is the easiest part of the game, which we just need to use the magic table. How can we use it? So we just need to divide the binary number starting from the right, and then we just need to match it according to the magic table, and then boom, we will get the number in hexadecimal form, which is 4216C000, and don't forget to put the subscripts, which is 8. So that's all for me. Now you can wake up now.
Okay. What is that dream? It teach me how to do arithmetic equation. I guess I can do it now. But I'm still sleepy, so I'm gonna sleep first.